Alright, today we're going to look at section 2.1, which is radical functions and transformations. So just to remind you that a radical function is any function that has a variable under the radicand. So the radicand, remember, is the part that's under the root. The index is that little number that tells you what kind of root you have. So this 3 would mean it's a cube root. If there's no number there, remember that that means it's a square root. So if there's no number, the index would actually be 2. It'd be a square root. And then we have the radical symbol. So again, any radical function has a root with a variable underneath the root. So the simplest radical function that you could have would be the square root of x. Now the square root of x has a very distinctive shape. If you were to make a table of values to describe the function, remember that you pick some x's and then you plug them into the formula to find your y's. Now, when I'm picking my x's for a radical function, I only want to pick numbers that are nice to square root. So the nicest number that I have, or the easiest, smallest number that I have that can square root would be 0. And when I square root 0, I get 0. Another nice number to root is 1. When I square root 1, I get 1. What's the next nice number that you could root? So 4 is with 2, and then 9 is with 3. So let's look at this graph. So again, it would start at 0, 0, then the point 1 and 1, 4 and 2, and 9 and 3. So those would be kind of the 4 basic points on your radical graph. Why does the graph not go into the negatives? So the negative numbers can't be rooted, so if you apply a negative 2 and then try square rooting the negative 2, that would just be an error, it'd be undefined, you can't do that. So that's why the graph stops at 0. It would continue on forever though in the other direction. So let's look then at the domain and range. So the domain of this one is all the x's are bigger than 0. So we'd say that x is greater than or equal to 0. 0 is the smallest x value that you have, all the others are bigger. Then let's look at the range. So the y values go as low as 0, and all your other y values are above 0. So we say that your y is greater than or equal to 0 as well. So that would just be the domain and range of your original radical function. Alright, so for example 1, we're going to sketch this radical function. Let's start by looking at this 2. Is that A, B, H, or K? It's H. Good. So here my H value is a positive 2. Remember that the original formula would have a negative sign in front of H, and the sign here is still negative, which means H is a positive 2. So H is 2 moves my graph 2 units to the right. Let's start though by drawing our original function. So now let's take our original function and move every point 2 units to the right, because we have an H value of 2. So your new graph will look something like that when it's moved to right. So let's look then at the domain of the right graph. So the domain now starts at 2. So all the x values are now bigger than 2. So x is greater than or equal to 2. The range hasn't changed. So the range is still greater than or equal to 0. So notice that your h value affected your domain. Alright, let's try our next one then. This time we have a minus 3. Is the minus 3 A, B, H, or K? It is K. K is minus 3. Be very careful. H would be underneath the root. K is going to be at the back, not under the root. So here K is minus 3, which means my whole graph is going to move down 3. So again, let's draw our original and then move it down 3. So your new graph is going to be this green one that has moved down 3. Now let's look at our domain. My x value is still all the x's greater than or equal to 0. But this time my ranges have moved. The ranges are down 3, which means my y's are greater than or equal to minus 3. So kind of similar to before, this time I have a k value, but notice that the range is changed by the k value. Domain was changed by h, range was changed by k. So this next example we're going to use mapping. to complete. First of all, we picked out our A, our B, our H, and our K from the equation, and then we plugged A, B, H, and K into mapping. You can pause the video here if you need a minute to write this down. Now into mapping, we're going to plug the key points from our original graph. So remember that the key points were 0, 0, 1 and 1, 4 and 2, 9 and 3. So that's what we're going to plug into mapping. So the first point, we're going to plug 0 and 0. Now, if I put a 0 into the x and a 0 into the y, we'll end up just with 1 and 2. Then we can try the point 1 and 1. So I plug 1 in for x and 1 in for y. So here we're going to get 1 divided by negative 1, so negative 1. But when I add 1, I'll get 0. So my x value is 0. 3 times 1 is 3, plus 2 is going to be 5. So the point 1 and 1 is now at 0 and 5. Please try the next 2 points on your own, so 4 and 2, and 9 and 3, and then check your answer with that on the board. So you can check that you got negative 3 and 8, and then negative 8 and 11. Now let's plot our points on the graph. So once you plot your points, you should end up with a graph that looks like this. Now let's take a look at domain and range. So the domain on this one has an x value of 1 as an endpoint, but then all your x's are smaller than 1. So we'd say here that x is less than or equal to 1. That's also because of the b value that was negative that flipped your graph. So notice that since b was negative 1, your graph is now, your domain is now less than instead of greater than, because your graph was flipped. The range is still greater than, but this time it's greater than 2. And that's because all your y values are above 2. So again, notice that the range is your k value, the domain is your h value, but then the signs happen because of the flips. Now example 3 is working backwards, so we have to go back and find the equation of the radical function. Now to do this, it's a good idea to first draw in where your original was. So 0, 0, 1 and 1, 4 and 2, 9 and 3. So my original would be somewhere in there. Now we can take a look at how it moved. So right away, I see that it moved over to minus 3 on the x-axis. Is that h or k? That's h. So h is going to be minus 3. How about k? Did this graph move up or down? No, so there's no k value, or k is 0. Now I need to figure out a and b. Now a and b is a little tricky. You actually need to be given 2 points that you are considering. So let's say that we're looking at these points, so that the points on the red have now moved to the points on the blue. So when I look at the red graph, it moved 1 over and 1 up, but these points moved 1 over and 2 up. So is this an A or a B stretch? It's A, because it's stretching taller. How many times taller did it stretch? 2. And was there any flip here? No, so there's no negatives to be considering. So that means our equation is 2 root x plus 3. Because when I plug a negative 3 in for h, the sign would turn positive in the equation. Now I told you that this was an a value, but if I had given you different points to consider, this could have been represented by a b value. So let's say that we're looking at these 2 points. Here, my graph goes over 4 and up 2, but this one only goes over 1 to go up 2. So this is the situation where now it's actually been made narrower. So your graph got squished narrower. What did I divide by to go from 4 to 1? 4 divided by 4. So to go from 4 to 1, we divided by 4. So that would be having a b value of 4 underneath the root. Well, let's take a look at this. Why would having a 4 under the root as a b be the same as having a 2 out of the root as an a? So that's because the square root of 4 is 2, So the b value could be removed as an a value when you square root it. Let's look then at our last example. This is a word problem. This says a company estimates its cost of production using this equation, C equals 20 root n plus 1,000, where C is the cost of production and n is the number of items produced. So first it says graph using technology. So I did that already. It's on here. Now if you look at the graph, let's talk about what the situation represents. So for part B now, it says interpret the domain and range. So the domain is going to be greater than or equal to 0, and the range is going to be greater than or equal to 1,000. But what does this mean? So remember that the domain is talking about n, which is number of items. So this is saying that you have to produce either 0 or more than 0 items. You can't produce a negative amount of items. Okay, so that's why your domain is going to be greater than 0. The range being greater than 1,000. What would 1,000 represent in terms of this cost? So 1,000 would represent the startup costs. So maybe the cost of the building or the a machine or something like that. Now finally, in these word problems, you're going to have to solve something. So here it says, what will be the cost to produce 12,000 items? So at 12,000, we're going to plug it in for n in your equation. So it'll be C equals 20 square root of 12,000 and then plus 1,000. So let's just calculate this. You have to follow BEDMAS, so we'll have to root the 12,000 first, then multiply it by 20, and then add the 1,000 after. So let's take a look then at these problems. So we'll take the next little while to work through them.